Hello everybody. Today we're going to take trig functions and put one inside the other. So get your unit circle ready and let's go. So just real quick, I know you've already done inverses, but let's just kind of a quick reminder as to where the actual inverse is allowed to live, because this is going to impact how we answer the question. So inverse cosine is only allowed here from 0 to pi. Inverse sine and inverse tangent are similar, not exactly the same, but they are similar in that they go from negative pi over 2 to pi over 2. So we got to keep that in mind as we go to start some of these questions. So it just kind of depends on what word is on the outside, and I'll explain that as we go. So as far as an inverse goes, right, x squared and the square root, that's how you get rid of each thing, right? That's what an inverse is. It undoes the problem. So we're going to have f, and then inside we would have the inverse, and then you just get x. Or if the inverse is on the outside and the function's on the inside, then you still just get x because they cancel each other out. So it seems like it's real simple, but you got to keep in mind the restrictions of the domain and the range. So for sine and cosine, so what I'm looking at is the outside word, sine and cosine. And you can picture the graph if you want to, but I'm going to use the unit circle because that's what you have in front of you. Or that's what you should have in front of you. So if you look at this, doesn't matter if you look at the x's or the y's. So the x's, the lowest number is there, the y's, the lowest number is there. So we know we're allowed to go from -1. And then the same thing is true for the x's or the y's there. So sine and cosine are only allowed to have answers between -1 and +1. Tangent, anything goes. Right? Because tangent has, if you think about the graph of tangent, it goes up and down forever, where sine and cosine are kind of bouncing back and forth between -1 and 1. So as long as this number for sine and cosine is between +1 and -1, and the problem is real easy. All right, so again, we're looking at this number right here. Those are the numbers we're looking at. So right here, since that number is between -1 and 1, these cancel. The answer is -1/3. Remember, arc cosine is the same thing as inverse cosine. 2/5 fits in between -1 and 1. So if you look at -3/2, right, this is -1.5. Ooh, that's beyond what we're allowed to have. So even though these cancel, the problem is this number. So this answer does not exist. Or, if you'd rather say no solution, something like that. But you can use DNE as an abbreviation for does not exist. Now remember, with tangent, you don't really care. Any big or small number doesn't matter, so that is -9/2. So when you see tangent and inverse tangent, you know you can go for it. Sine and arc sine, okay, those cancel, but -7/6, that's beyond -1, because 6/6, that's one more, so this does not exist. So you got to be careful. So let's put the inverse on the outside. When the inverse is on the outside, changes things a little bit. Again, we want to make sure that this angle inside here is something you're allowed to do. So first quadrant, sine, and it's up here. Sine is allowed in the first quadrant, right? So we're good, right? Sine is right here. Sine's allowed in the first quadrant. So that's what we're referring to now. So since that's okay, these cancel. The answer is pi/4. Cosine, this is in the second quadrant. Inverse cosine is allowed there. So this is going to cancel, and the answer is 5pi/6. -pi/2. Tangent. Tangent is not allowed to touch this line. Sine is. Sine can be on this line. But tangent, no, that's an asymptote. So, since it's not allowed to touch that line, it's trying to touch the line, so we can't have that. So this does not exist. Yes, this cancels. That's not the issue. The issue is that angle is something we're not allowed to do for tangent. Sine is allowed. Negative pi over 3. Sine's allowed there, so we're good. So this is negative pi over 3. Now, for this one, and this is a really good hint, tip, whatever you want to call it, which is why I left it there. All right, all of this. If the angle is outside of the domain, rewrite it using an angle that's inside the domain. Okay. So 3 pi over 4. Let's think about 3 pi over 4. If you look at the unit circle, 3 pi over 4 is right here. Sine, inverse sine is not allowed there. So look at your unit circle. Is the sign positive or negative? Is the y value positive or negative? It is positive. Where else is the sign positive? All scholars take calculus. So sine is also positive right here. So another name for that angle that has the exact same answer would be pi over 4. So we have arc sine times the sine of pi over 4. So because this and this have the same answer, I know they're not the same spot, but they have the same answer on the unit circle. So you got to look at the unit circle. That's how you would do it. Those would cancel, and this answer is pi over 4. Tangent of pi. That's over here. You're not allowed there, right? Tangent goes from here to here. You're not allowed here or here. So what angle has the same answer as the tangent of pi? Well, 0, right? Because they both have the answer is 0. So I know this is 0 radians, but the answer is also 0. So now we have inverse tangent of the tangent of 0. And these are gone. Sine of 11 pi over 6. Well, that's a nice spot, but we're not allowed to get to it like that. We have to get to it for like this. We have to go 0 down. We're not allowed all the way around because we're not allowed over here. So that's the same thing as the sine of negative pi over 6. So now the answer is negative pi over 6. Really and truly, you could switch this at the end. Like I'll do it this way. You could cancel this out, right? So you know that's going to be gone. The problem is for cosine, you're not allowed to call that angle negative 4 pi over 3. So this is how you get there. But look at your unit circle. What is the name of this angle right here? It's 2 pi over 3. So the answer is really 2 pi over 3. So you can change it first, or you can change it last. It's totally up to you. But you've got to keep looking at the circle. That's where all the answers are. Now, honestly, it gets a little bit easier when we have 2 different words. It just does, because then you don't have to really quite pay so much attention to the rules, right? So now we're just straight up looking at the unit circle. So you start on the inside always, because it's a math problem with parentheses. And so we're going to leave this out there, so we leave this alone. What is the sine of pi over 6? Well, you go to pi over 6, you look at the y value, and it's 1/2. Now the question is, what angle, because you're looking for the inverse, has a cosine of 1/2? Okay, well, pi over 3. Look at the unit circle. The answers are on the unit circle. If you're not looking at the unit circle, you're probably wondering how I got these answers. What is the cosine of 0? So we're going to leave this arctangent alone. The cosine of 0 is 1. So what angle has a tangent of 1? Remember, there's 2 places, right? There's a here, here, and here, but you're not allowed here for inverse tangent. So therefore, there's only one answer. So now we have inverse sine. Oops, that's. And now, what is the tangent of pi over 4? Well, we just did that, right? So that's negative 1, because it goes down here. So negative 1. And what angle has a sine of negative 1? Be careful with this. The answer is right here. You're not allowed to call that 3 pi over 2. You have to go 0 down. So negative pi over 2. Look at the unit circle. Arc sine. What is the cosine of 5 pi over 6? Well, it is negative radical 3 over 2. And what angle has that cosine? Well, the answer is really 5 pi over 3. We'll do this one a little bit different. But you're not allowed to use that. So if you're looking at the unit circle, it's right here. So what the real name for that is, in terms of what we're allowed to do, because we're not allowed to go around, we have to go 0 down. So you have to call this one negative pi over 3. Inverse cosine. The tangent of pi over 4 is 1. What angle has a cosine of 1? You have to be looking at the unit circle. The sine of negative pi over 2, right? So that's straight down. That's a negative 1. What angle has a tangent of negative 1? So tangent is negative here and here, but you're not allowed over here. And this answer is just be down. So you have to call that negative pi over 4. Repetition is essential here. You've got to start getting used to looking at the unit circle, getting used to some of these numbers. These answers are just repeating. I don't know how many times we ask the same question over and over again. It's just the way the unit circle is. What is the sine, or what angle has a sine, rather, of 1/2? Well, that's pi over 6. Cosine of pi over 6. So you don't have to look very far on that one. You're looking only at the pi over 6 angle. What angle has a tangent of 1? Well, we just did this, right? It's pi over 4. Actually, right here. And then what's the sine of pi over 4? Radical 2 over 2. So if you really try and you pay attention, you'll see a lot of the same things being asked. It's just, like I said, it's just the way it's going to be. What angle has a cosine of 0? That's pi over 2. And the sine of pi over 2 is 1. Leave the cosine alone. What angle has a tangent of radical 3? Well, if you remember my tangent tricks, that if there's 1, 3 in the answer, then there's 1, 3 in the question. So it's pi over 3. Now you look at the unit circle. What is the cosine of pi over 3? So the unit circle is right here, right? That's where pi over 3 is. Cosine is x. It is 1/2. Please make sure you have the unit circle available, whether you pull it up on your phone or you have the actual paper to look at. Make sure you have that. This is going to be real hard to do without it.